Hello guys, I'm back with another video. So in this video, I'm gonna walk you through how I implemented Kafka from scratch in C. This video is so exclusive that there's no one on YouTube that made a video about how we can implement Kafka in C feature by feature, exploring all the operating system level internals. So let's get into the Kafka GitHub page. So this is of course an open source project, so you guys can fork this repo and make changes to it. So this is the GitHub README page. So look at the picture logo. It's super amazing. Like, I named it Kira Kafka because Kira, it's like God something according to DeadNote. So Kira Kafka. So this is the distributed system implemented from the features of Kafka. So as I told you before, feature by feature implementation of Kafka. So these are the features that I've implemented into my Kafka system. So firstly, topic and partitioning. So the topic structure and the partitions that are included inside the topic, and also the brokers of the Kafka. So before getting into this, you should know how Kafka works internally, like the architecture of Kafka. For that, I'm gonna drop a link to my video below so you can see how Kafka works. So the second feature is disk-based log storage. So Kafka implements this based on append-only logs. So all the messages that is being sent to the stream will be stored in the disk based on a log system of files. We'll get to that in my code structure. And zero copy reads. So the direct transfer from the disk and to the kernel buffer, from the kernel buffer to the network buffer. So direct zero copy reads, and memory mapped IO for fast reading from the disk without using system calls such as read. So I've implemented that using mmap. So it's going to be very interesting. And the thread code affinity, which means we are going to basically map a particular thread to a particular core for efficiency purposes. And flush daemon, which means we are going to get the data from the file without using read and other system calls. So it's using fsync without using memory mapping technique. So using fsync and load balancing technique using round robin, and it's open source friendly, of course. So yeah, these are the features that I've implemented in my Kafka. Moving on to the project structure, guys. This is a wonderful project, as I can say, because each of the features in Kafka is implemented on separate folders. So you can run each, you can get to know more about each of these features by accessing through each of this particular folder structure that is divided into this particular folder called source. So in the append log, if you move to the append log, you can run that particular append log to see how it works. And mmap and partitioning, thread code, zero copy, everything. You can run segment by segment, everything inside this one beautiful project structure. So I've used makefile for running it, and of course we have discussions. Yeah, discussions. You can move on to discussions, and I've got you an amazing thing called Kira Kafka wiki. So if you get inside here, you can see this homepage, and you can get to know a little bit more about how these features work, like zero copy. I've used the system call called send file for direct copying from the kernel buffer to the network buffer system using send file, and disk-based sequential log appending. So here I've included write and fsync for transferring the data from disk into this particular log system. So storing the messages in the form of log into the disk, so that the messages will be persistent on the disk. And memory mapped files, so Kafka uses for fast read access. So without basically using read syscall, we can memory map that particular address of the data from the disk into our user space, so that there's no need for any read and write calls. And since the data is actually stored into our virtual memory space, so it works like this, guys. You got a process and it's requesting data to be accessed from the disk. So using this memory map function, we are going to take the pointer to that file's address located on the disk, map it to our process virtual memory space, and when it reads from that particular virtual memory space, it's gonna create something called, I think, page fault. Yeah, page fault, so that when the page fault occurs, the kernel's gonna load that disk file, the contents of the file, into the virtual memory space of the process. So the entire thing is loaded once, and it can read multiple times without using multiple read system calls. So that's how memory mapping files work. And partitioning, so using partitioning, we are going to divide brokers into topics and partitions. And thread to core mapping, this is essential, guys, because each of the thread, which may be network IO threads or consumer threads and other kinds of threads, and like log flushers, like flush the files content into freeing the files content. So these type of threads exist on different cores. So each of the cores, we can easily divide the particular functionality of each core for fast access and other functionalities. And log segment and index files. So in the .log file, we are going to save the messages, and .index for the offset and byte positions, and the time index for setting the time. So this is the wiki page explaining the features of Kafka. So let's move on to discussions. So here's the discussion. Most of the features are explained by me in this one, like how they would work in Kafka. So if you want to add more features that I haven't included in this repo, you can do so. I appreciate that. I appreciate your work, and you can discuss about it in the discussions. So moving on to the code. So I think I've explained. And contributing, yes, that's the main purpose of open source. You can contribute. So yeah, submit a pull request. I approve each and every one of your pull requests. So yes, moving on to the code. Yes, code. Most of the code is written in C. Each line is written in C. Every line is very simple to understand. So I'm just going to give you an overview of how each of this works. As I think explained each of the features before. So let me just go to the partitioning one. So yeah, we've got brokers, consumers. So in the broker, we are going to have the topics inside brokers and the top number of topics for each brokers. And in the consumer part, the consumer is basically, you got a broker and you got a producer and a consumer. So the consumer is gonna subscribe to the producers that to the particular topics in the broker, so that it can get the messages from the producer. So that's what consumer does. And the producer produce messages. And topic, inside the topic, we are going to have the partition count, and the round robin index. Okay, let me just zoom in for you guys. So round robin index, so it's basically used for load balancing. So if I got two partitions, it's gonna divide, if I got multiple messages, it's gonna divide that between those two partitions. So it's gonna balance the messages between the partitions. So that's what it does. And then we are moving on to the source file. In the broker, I'm creating a broker. I'm going to get the topic, adding the topic. these three things are being done in the broker part. So that's what it does, and consumer and producer and everything. Yeah, that's consumer is gonna consume the messages, producer it's gonna produce the messages. So that's what partitioning does. It's gonna divide that particular message into partitions of specific topics. So I think it would be better if I run this one. So guys, this is super simple. So if you just skim read to all the coding lines, you can easily get to know what I'm doing with this. So let me just run this partitioning to show you how it works. So let's go to the main file. So I'm basically creating 4 threads for running each of the messages, each of the consumer messages. So the producer is going to produce the message, and the consumer thread is going to get the message from all the producers. So I'm going to create 2 brokers, one broker, 2 topics. The first one is orders and the logs. So firstly, message 1 sent to topic orders in the partition 0, and login also sent to partition 0, and order 2 and order 3, like that. So this is how Kafka divides topics into partitions, and the producer is going to produce the message, and the consumer is going to get the message from the topics that it has been subscribed to. So this is the partitioning part. Let's move on to the zero copy part. So this is very interesting. I already ran this one, so I got the orders file .log file here. So I'm just gonna show you the code here. So yeah, so we are having a server. So the zero copy mechanism for my Kafka works like this. It's gonna have a socket, as you can see here. We are creating a socket which is listening to the port 8080. I said that in the main file. Yeah, here. So it's listening to the port 8080, and then we are going to send a file. We are going to set a connection. We are going to bind the socket and to that particular port, and we are going to create a client, and that client is going to accept the connection from the, I think, the server. Yeah, so the client connecting, sending the file. So we are going to send the file from the client through the socket. So after sending it, what I'm doing here, yeah, to the socket, and here's where I'm using the send file function. So with the help of the socket, I'm going to send the file from the kernel buffer to the network buffer. So that's what it does. And yeah, so it's going to send it, and after sending the file, I'm going to get a log file. After what are the contents from the client, I'm sending it from the kernel buffer to the network buffer. So it's basically order 101, 102, and the 103. So this is how zero copy works. So without copying the file into the user space, we are directly using that, sending it to the network buffer. So that's zero copy for you. And then memory mapping. I explained memory mapping before in a clear way, I guess, because it comes with virtual spaces. So yeah, so I'm going to read the file. I'm going to open a file. I'm going to read it, and I'm going to write the contents via mmap function, and I'm going to write it to the file, and I'm going to unmap from the memory mapping thing. So that's what I did over here. And append log, this is one of the core features of Kafka because it's super amazing to look at it. So let me just, so in my code, it will create you a temporary folder. So in the folder .index, I'm going to get the, this is the file descriptor. So 0 and 1 are file descriptors, which means standard input, standard output, and the files open or not. So it's going to be a global file descriptor. And 23, it's the offset value. So I think, let me just show you the code for you guys. So yeah, see here. So here I'm going to create a log file, and each of the log files is gonna have a file descriptor so that it will be easy for the kernel to read. And I'm using lseek functions so that to get the offset address for the next file. So in the index file, you can see this 23. So 0 is the starting point, and the lseek is gonna move the pointer to the end of the file. So that's going to be the starting point of the next file, which is 23 offset. So in the .index file, we are going to get the offset address. So from the offset address, we can easily access the files which are located on different locations. So that's offset in the .log files. So Kafka is going to store 3 files, which are .log, .index, .timeindex. So in the .log file, it's where the main messages are going to be located. And in the .time file, we are going to have the time on which the particular offset is created, or the particular file is placed onto that particular offset. So here I've used lseek function and the write function for writing the file descriptors. So when you're using file descriptors, use system calls such as write and read. I'm going to fsync for directly moving the file descriptors to the disk. So the data to the disk, I'm going to close it, and then I'm going to move the log offset. So how many offsets are created for the particular partition. So that's what I did in the append log. And in the thread code, this is super interesting because I'm going to map a core to a thread. So let me just show you guys the code. So this one, the thread to core mapping, note this guys, it's gonna work only on Linux based systems because I don't know what is going on with the Mac. The Mac scheduler is going to have its own shelling properties, so we can't map this thread to its core. This pre-thread set affinity NP is going to map the thread to the particular core. So we are setting this new source hashtag define because that's going to help us run this particular system level thing called pre-thread set affinity NP. So that's how these cores are mapped to the particular thread. And we are going to set that, and we are going to set affinity to the particular CPU, and that's it. That's what we are going to do in bind thread to core. And in the network IO thread, I'm going to mimic a thread called network IO, and log flash thread, I'm going to mimic that particular thread, and consumer thread, I'm going to mimic that particular thread. That's what I did here. In the log file, you can see how many flash. I think these are log flash things so that we can get to know what are the files that are fleshed out from the disk. There is some particular timing for this. I think log flash timer in Kafka, how much time the data is going to be persistent on the disk. So flash, it's going to flush the data from the file. So this is how the thread core works. I think I covered everything over here for you guys about how Kafka works. So let's move on to here. Yes guys, that's it. That's how I made Kafka for you guys. So I'm a sophomore. I created this to improve my understanding about how Kafka works because I don't want to just write code before knowing anything what's underneath it, what's happening under the hood. So that's why I created this open source project called Hero Kafka. It's basically super simple. You guys can fork this and make this into an amazing one based on your preferences, of course. And code of conduct, yeah, so these are just for formalities. Yeah guys, that's the Kafka I made. You can see in C from scratch, of course, based on my level of understanding. If you guys think that I made some silly mistakes along the way, please feel free to comment that below. So yeah, like this, share it, and subscribe, and see you guys again with the next awesome video. Bye bye.